The next problem is similar to the and to understand the jobs of scheduling. So question number two. The table he has given as jobs of scheduling. So six jobs are given J1, J2, J3, J4, J5 and J6. So the six jobs are processing on two machines 4, 5, 6, 8, 7, 1, 8, 3, 9, 6, 1, 10. So as per our first step is to find the optimal sequence. So to find the optimal sequence, we need to have first start with what is the least processing time in the machine. So optimal sequence, six jobs, 2, 3, 4, 5. So least processing time is 1. It is there with machine 1 and machine 2. So both. For that case, take the machine 1 and job 1, job 6 on machine 1. Take the job 6 on machine 1 and keep it on, because as per our definition, if there are two or more than one same minimum processing time, select any of them randomly and assign the sequence. So I selected job 6. So job 6, that least value is with machine 1, so assign is first. So another list value is job 3 of machine 2. So it is on machine 2, assign it last. Next list value is 3, which is with J4 on machine 2. So assign it last. Next list value is with J1. It is again with machine 1. J1. Next list value is with, that is 7, sorry 6, with M1 again. So J2. Remaining one is J5. The sequence is optimal sequence is J6, J1, J2, J5, J4, J3. This is the sequence. If each machine follows, then it will increase efficiency and it will reduce the processing time. To calculate the make span time after getting the sequence job J6, J1, J2, J5, J4, J3. These are the jobs, and the next is processing time of each job. Processing time here is assigned as Ti in all our future notations. Processing time of 1 J6 is 1 and 10, 4, 5, 6, 8, 9, 6, 8, 3, 7, 1. Next, machine 1 scheduling. Machine 1 in and out. So machine 1 enters at 0 time. Sorry, a job enters into machine 1 at 0. For 1 minutes it come out. After if it is 1 minute or 1 hour or 1 day, depending upon the units, so 1 hour it comes out. So again it after 1 hour the J1 will enter and its processing time is 4 minutes or 4 hours. One zero five 5 to 11. Okay. Next 11 to 9 plus 9. 11 plus 9 is 20. 20 plus 8, 28. Sorry. 28 plus 7, 35. So for machine 1, there is no need to wait for any other thing. So it can run continuously. In and out. And machine 2. So the suppose the J6 job, the job J6 entered machine 1 at 0 time, that means the beginning, and after machining takes place 1 hour it came out. So and then after coming out of that it enters the machine 2, that means in after 1 hour. So machine, what is the here it will leave at 11 because the processing time in machine 2 is 10 hours, so it will leave out of the machine 2 after 11 hours. Overall, after 11 hours, by the end of the 11 hours, job 6 will complete its machine processing in both machine 1 and machine 2. Next, after 11 hours, it will start machine job J1 in machine 2, and it processing time is 5 hours, right? So 11 plus 5, 16. So by the time 16 hours over, so job 2 J2, which is shown as a time out of the machine 1 is 11 hours. So by 16 hours it will be free waiting for to machine empty, machine 2 empty. So job 6 one, the time job 1 leaves the machine 2, job 2 enters. So it enters at 16 hours, after 16 hours from the beginning. So what processing time here is 8 hours. 16 plus 8, 24. 24, it will start J5. 24 plus 6, 30. So job 4, by the end of the 28 hours, it will complete in the machine 1 its processing. So it will be waiting for machine 2 to be vacant. So once the machine 2 is vacant, 30th hour it enters, and it processing is 33 hours, no, 3 hours. So after 33rd hour it comes out of the machine 2, but job 3 is still in processing in the machine 1. So job machine 2 has to be idle for 2 hours here. So then after 35th hour, machine job 3 will be free from machine 1 and it will come into the machine 2. So for overall here machine 2 will be idle for another 2 hours. So total make span time into 36 hours. So idle time of machine 1 by the end of 36 hours, 1 equal to 36 minus 35, okay, equal to 1 hour. So idle time of machine 2 equal to beginning 1 hour plus when the job 4 enters, and when job 4 leaves from machine 2, 33 hour, 33rd hour, by the time job 3 still in the processing stage of on job machine 1. So it takes 2 hours idle time for machine 2. 33 to 35, if you see there is a gap here, this gap 33 35. So by this time the machine was idle. So total 3 hours. So they can give the problem like, idle cost for machine 2 is 500 per hour. So what is the total idle cost by the end of the entire process cycle? This is one. So then you have to multiply the number of hours into the idle cost. That is the loss of the machine. Next is, so just now we have seen two machines, n jobs. N jobs means jobs may be more than two. Next is n jobs, n machines. What is the procedure? N machines and n jobs. If we have n machines and n jobs. So here, if we have n jobs and n machines, we need to convert this into two machines and n jobs. So n machines, n jobs to two machines, n jobs. Here the problems which we have done is two machines and n jobs, so which are simple to solve. So yeah, even the problems of more than two machines also we have to convert them into n machines and n jobs. Step 1. Convert the n machines and n jobs problem. N is the number, problem into two machines, n jobs. and then solve with two machines n jobs method. So for this few conditions we need to remember. So first of all, for example, we'll write theory for this correspondingly. Then we will solve one problem which gives clear picture of how to solve the. There are more than two machines, so they have given gate question also once. So that's why we need to solve for this. Especially if you are preparing for IES or some other exam, definitely helps. Okay. So next we have, so how to convert step, how to convert is, so for each machine we have the time for machining, processing time for each machine we have. So convert the, suppose job I, 1 2 3 4, so n jobs. Machine machine 1, machine 2. We'll take simple example of three machines. So the same example will be suitable for other machines. T11, T12, T1n. T11 is the processing time of machine job 1 on machine 1. Similarly, processing time of job 1 on machine 2. T22, T2n. So similarly, processing time of job 1 on machine 3, 3 2, 3n. So after raise, this is I will write one simple process T. Suppose for example T31 equal to processing time of job 1 on machine 3. So once, if we have, suppose initially we have three machines here, we need to convert 3 to 2. Two hypothetical machines. Consider two hypothetical machines. Machines R and S. So TIR is equal to TI1 plus TI2 in a reverse format. So TRI, okay, I should have written because I have taken the table in row format, so that's why it has to be changed. Time of job 1 on machine R is equal to T1I plus T2I, where I is the job number and 1 is the machine 1. Ri is equal to, so Ri is equal to T1I plus T2I. So suppose for example I equal to 1 means 1 to n. So R1 equal to T1 plus T11 plus T21. Don't get confused. If you do one problem, then it will be clarified. I should have taken this row and column. It's okay. So Si equal to T2I plus T3I. Again I equal to 1 to n. So you need to combine first n minus 1 values and second n minus 1 values and make sure that one condition is minimum of Ti3 or sorry T3I is greater than maximum of T2I and minimum of T1I is greater than maximum of T2I, greater than or equal to. So then we have to use Johnson's algorithm. Minimum of this tells, suppose for example if you have A, B, C, presently three machines, the minimum time processing time in machine A is greater than minimum processing time in machine A is greater than or equal to maximum processing time in B. Same way, minimum processing time in machine C greater than or equal to maximum processing time in B if we have three machines. Suppose if we have A, B, C, D machines, then minimum processing time in machine A is greater than or equal to maximum processing time in B and C. So whatever is the middle between the extreme machines, whatever the number of machines in the middle between extreme machines, suppose if there are 100, then maximum of those 100 machines processing times. So minimum of processing time in machine D, so only we need to consider a minimum of extreme machines D is greater than or equal to maximum of processing time in B and D again. So I think you got some fair idea. Instead of I and number, if I take, I mean, if explain in terms of 3 4 machines, then it's clear idea. Even if we have another machine, then maximum processing time in BCD, like that it will come, whatever the middle machines. So if this condition satisfies, then only it will go to the next step, otherwise it won't. So Johnson's algorithm won't satisfy, so to calculate the you know optimal sequence, it is difficult. So after calculating the hypothetical machine times, so then you'll convert into machine to, once this condition satisfies, then we convert n machine to jobs, sorry, n jobs to two machine n jobs, otherwise we stop here. So after completion of this, so calculating, so once after converting the n jobs, either two machines to or two machines n jobs to, then step 3 is calculate optimal sequence for two machines and n jobs problem. So we have converted n machines to two machines. So we have to calculate optimal sequence. After calculating this, calculate the make span time and ideal time. And ideal time of each machine. So we do one problem, n jobs, like three jobs and n machine, sorry, n jobs and three machines, then it will give us clear picture. So generally here, in a gate exam, they won't give more than three machines n jobs. Mostly, whenever they gave the question, they gave is two machines and n jobs only. We need to check those conditions. These minimum conditions is, we need to check only if there are more than two machines. If there are two machines exactly, then no need to check also. You can directly use the calculate the optimal sequence and then go ahead with calculating the make span time. So these are problems are very easy, but only thing is you need to be if you once practice, spend 15-20 minutes, and then it will be clear. If you won't practice, then you don't, definitely it's very difficult to solve, because these are straightforward questions. There is, he can't insert in some other topic into this like some, if you look at the fluid mechanics or thermodynamics or thermal question or any other questions in the material, they can combine 2 3 topics and ask questions, but here it is not, so that's advantage. Okay.